The aim of this lecture is to provide an understanding of the hazards, controls and monitoring throughout food storage, preparation, thawing, cooking, cooling, reheating and serving. And the learning outcomes by the end of this module, you should be able to identify how food is contaminated, how bacteria multiply and how they survive, state when toxins are formed and when spores germinate, and explain the various cooking processes. Lastly, state the various temperatures required under law for cooking, reheating, chilling and freezing. It's assumed that the following prerequisites are in place at all relevant stages: satisfactory design and construction of premises and equipment, adequate facilities such as water supply, drainage, waste management, cleaning facilities, storage areas, lighting, ventilation and temperature control, the use of approved and reputable suppliers, effective cleaning and disinfection where appropriate, maintenance contracts, good personal hygiene, training, staff controls, staff vigilance and effective supervision, competent staff, integrated pest management, contingency plans, satisfactory transportation, which protects food from contamination and prevents multiplication of microorganisms, and lastly, product information and clear labelling. Let's start with delivery and unloading. Under Regulation EU 852/2004, contaminated or decomposed raw material which would remain unfit after normal sorting and hygienic preparation must be rejected. The hazards of contamination by microbiological, physical, chemical and allergenic means and multiplication. Controls: choose the safest ingredients, use approved suppliers, set suitable specifications. Monitoring, checks and recording could include audit suppliers' premises and records, history of deliveries, complaints, bacteriological sampling, customer references, food safety systems in place including HACCP documentation. So the main controls with delivery and unloading are, first of all, to use approved suppliers. No food should be exposed to the risk of contamination. There should be specific delivery requirements specified. Chilled food less than 5 degrees Celsius, frozen food less than -18 degrees Celsius, and delivered in a refrigerated delivery vehicle. Quick removal to store in under 15 minutes. Food protected and covered, and a separate deboxing area. The different types of monitoring: food temperatures and time. Reject above 8 degrees Celsius or above -12. -15 degrees Celsius for quick frozen food. Inform line manager if any food delivery is rejected. Condition of delivery vehicle and driver, including any toxic chemicals that might be delivered on the same food vehicle. Condition of packaging, date coding, labelling, organoleptic checks on food where practical. This is quality and quantity. Organoleptic checks means using your senses. Also, condition of canned foods. Under Regulation 852/2004, all food must be protected against contamination during handling, storage, packaging, display and distribution. Satisfactory storage of food is important, first of all, to ensure adequate provision throughout the year, to overcome fluctuations in supply, to take advantage of bulk discounts, to maintain safety, quality and wholesomeness. Satisfactory temperature control and an effective stock control system are crucial to food safety. Storage conditions for different types of foods include, first of all, raw meat and poultry between -1 to +1 degrees Celsius and to hang where possible. The storage of eggs, clean and dry, below 20 degrees Celsius, used within 21 days. Meat pies, pasties and sausage rolls, below 8 degrees Celsius if nothing added after cooking, otherwise below 5 degrees Celsius, and rotate stock. Ice cream below -18 degrees Celsius or -12 degrees Celsius prior to serving. Milk and cream, which includes imitation cream, below 5 degrees Celsius, refrigerated on receipt, and good stock rotation. Flour and cereals, kept in a clean, dry and cool room, in pest-proof containers where possible. Sacks, etc. stored a minimum of 15 centimeters off the ground, and good stock rotation. Canned foods, again kept in a clean, dry, cool area. Fruit and vegetables, optimum conditions vary with type of fruit. Generally cool and dry conditions are required, and try to avoid physical damage. Ambient or dry goods storage. Hazards include contamination, especially from pests, multiplication, especially when dry products become damp. Problems include spoilage, mold growth and staleness. Good hygiene practices. Stores should be well lit, ventilated and pest proof. Controls include good stock rotation, cool, preferred temperature range 10 to 15 degrees Celsius and dry, clean and tidy, good housekeeping practices, cleaning away spillages, goods clear off the wall and off the floor, a minimum of 15 centimeters. This is mainly for ease of cleaning and should check for any signs of pest infestation. Rodent proof containers, which are protected and covered. No chemicals, they should be kept in a separate store. No incompatible goods, such as strong smelling goods. Care with handling. Separate the boxing area prior to storage if possible. And suitable shelving, preferably slatted for ventilation. And not made from wood unless the wood is sealed with paint or varnish. It's far better to use a metallic substance like stainless steel or aluminium. Monitoring includes audits and inspections, date codes, condition of food, condition of packaging, condition of canned food. Defects of cans. The hazards here are contamination and multiplication. And the various defects of cans include they could be punctured, they could be dented, so the seam could be damaged, they could be blown, there could be a flat sewer. This is where acid produced but no gas or swelling of can. Rusty. It could be a flipper where the end bulge pushes back. It could be a springer. The end bulge goes to the other end when pressed. Or it could be a soft swell. Both ends are slightly extended. Or a hard swell where both ends are greatly extended. It could be a hydrogen swell where gas is produced with acid fruits. And labels missing where the contents are unknown. Blown cans or vacuum packs usually occur because of the production of gas by bacteria, or in the case of cans, the production of hydrogen from the reaction between acid food and the can wall. Food in blown or damaged containers may be contaminated with pathogenic bacteria and should not be consumed. Unfit, damp, damaged, contaminated or out-of-date stock should be rejected and kept separate. For example, placed in a container marked unfit for human consumption, do not use. The controls here would be to use an approved and reputable supplier, care in handling and good stock rotation. Monitoring would include regular audits of the storage conditions and visual checks on the cans themselves. Under Regulation EC 852/2004, where necessary to provide suitable temperature-controlled handling and storage conditions of sufficient capacity for maintaining foodstuffs at appropriate temperatures to be monitored and, when necessary, recorded. The hazards here are contamination and multiplication. Note well, some bacteria may multiply slowly in a fridge, for example Listeria, Clostridium botulinum type E, and spoilage bacteria. Vacuum packs of meat, fish and other high-risk or perishable products must be stored under refrigeration and used strictly in accordance with the use-by date. Reduced level of preservatives, for example in sauce, means bottles should be stored under refrigeration when opened. Controls include the operating temperature 1 to 4 degrees Celsius. The legal temperature, food to be held below 8 degrees Celsius or at 8 degrees Celsius. Advise line manager if food is above 8 degrees Celsius immediately. Another control, the use of alarmed units, avoiding high humidity. Separation of high risk and raw foods. Note well the risk of drip from raw meat to salad or high risk food. Separate eggs from high risk food. Cover food. Good stock rotation. Reject unfit, contaminated or out-of-date food. Do not overload or exceed the load line. Do not open the door for longer than is necessary. Ensure door seals are in good repair and clean. Effective defrosting, preferably automatic, cleaning and disinfecting, and easy clean construction. No hot food to be put in fridge because it will raise the temperature of the fridge, so cool the food for 90 minutes prior to refrigeration. No open cans, especially acid food. Label food when necessary. There should be staff training and supervision. Eggs should be stored cool and dry at less than 20 degrees Celsius and avoid fluctuating temperatures. If 21 days or older, they must be stored in a fridge. And lastly, a maintenance contract on the fridges themselves. Monitoring includes checking and recording temperatures, regular audits and inspections, check condition of food, and observance of date codes, especially the use by dates. And checking temperatures, check dial temperature at the start of the day and regularly throughout the day. Check and record temperature using an accurate, calibrated digital thermometer at the beginning and end of the day. Check the warmest part of the fridge, which is always the top shelf. And the best way to check temperatures is to put an item such as a glass of water or perhaps some solid vegetable fat wrapped in cling film and labelled do not use, and put that on the top shelf of the fridge and check the temperature of that product throughout the day. Don't rely on the digital readouts on the front of the fridge because they just check the air temperature. Because obviously when somebody opens a fridge, warm air rushes into the fridge and cool air rushes out. So you might look at the air temperature or check the air temperature after somebody has just opened the fridge and it could give a wrong reading. So always use a product such as a glass of water or solid vegetable fat to actually check the temperatures. The hazards with frozen foods are contamination and multiplication. Bacteria do not multiply in a freezer unless there's a serious temperature abuse and thawing of food. Some spoilage organisms can grow as low as minus 10 degrees Celsius. Enzyme action can cause problems even in frozen food. And there should be a contingency plan for freezer breakdown, which really is a prerequisite. Controls for frozen foods include storing at less than minus 18 degrees Celsius, or minimum of minus 18 degrees Celsius, the use of alarmed units, reject if above minus 12 degrees Celsius, or minus 15 degrees Celsius if quick frozen food, which you can thaw and use as fresh. Thawed food must not be refrozen. Do not load above the load line. Effective stock rotation, handling carefully, suitable packaging to make sure everything is covered, wrapped and labelled with a date and a description, prevent temperature gain, separate raw and high risk foods, and do not open the door for longer than is necessary. Monitoring methods include checking the temperatures regularly, audits and inspections, checking the condition of food, and the observance of date codes. Also reject unfit, contaminated or out of date food. Storage times: vegetables, fruit, most meat up to 12 months. Pork, sausages, offal, fatty fish, butter, soft cheese up to 6 months because of the high fat content, which after that period of time it will tend to go rancid or oxidize. And the problems with prolonged storage include loss of texture, flavour, tenderness and nutritional quality, rancidity or oxidization in fatty foods, freezer burn or evaporation of liquid from the product, and freezing and refreezing. Thawing frozen poultry. Regulation EC 852 2004 states that the thawing of foodstuffs is to be undertaken in such a way as to minimize the risk of growth of pathogenic microorganisms or the formation of toxins in food. The hazards here are contamination and multiplication. And controls include: use fresh or chicken portions where possible, separate from high risk and other foods, thaw completely to about 10 degrees Celsius, check if thawed completely, i.e. pliable, legs flexible, no ice crystals. The best thing to use really is a probe thermometer. At least then, by checking the thickest parts of the poultry, you'll know that it's defrosted correctly. Refrigerate when thawed and cook within 24 hours. Always remove giblets. Cook thoroughly to 75 degrees Celsius core temperature. Cook stuffing separately. Clean and disinfect contact surfaces including equipment. Eat immediately or as soon as possible after cooking or rapid cooling, or keep above 63 degrees Celsius. There are risks of inadequate thawing, risks of cross-contamination, especially from the thawed liquid. Minimize handling of cooked bird, always wash hands after handling. Thawing, that could be undertaken in a thawing cabinet, in a cool, well-ventilated room around 10 degrees Celsius, under cold running water at less than 15 degrees Celsius, in a fridge or a chiller. The weight of the bird and temperature of the refrigerator are critical to the thawing time, which does tend to take a lot of time in a fridge, and the use of a microwave, following the manufacturer's instructions. The main danger is failure to thaw completely prior to a predetermined cooking time. Thawing in a fridge at around 1 to 4 degrees Celsius can be very slow, and if inadequate time is allowed, the bird may still be frozen in the centre. Thawing overnight, even at around 20 degrees Celsius, is perfectly safe, as the temperature of the chicken will be too low for most of the time to allow salmonella to multiply. Salmonella on the surface will be easily destroyed during normal cooking anyway. Staphylococcus aureus, even if present, does not compete well with spoilage organisms and will not produce exotoxin below 15 degrees Celsius. The final safeguard is to ensure the coolest part of the bird achieves 75 degrees Celsius during cooking, usually the deep thigh. Stock rotation ensures that older food is used first, using the acronym FIFO, first in, first out. So with new stock coming in, that goes to the back of the shelf and the old stock comes forward. It avoids spoilage, mould, slime and unfit food. It avoids wastage, loss of stock, infestations, guarantees a constant quality and customer satisfaction. It maintains correct stock levels. It reduces risk of pest infestation. Stock management, need to ensure that you label accurately, especially the description of the products and whether or not there are any allergens in the product. Specific storage information, for example below 5 degrees Celsius. Daily checks for short life foods, weekly checks for other foods. Written stock control records are recommended. And the coding of food. Food should be colour coded or date coded. And there are 2 dates in existence, legal dates, and these are used by dates and best before dates. A use by date is put on perishable high risk foods and foods that can support the growth of pathogenic microorganisms. It's considered unfit after that date, and it is an offence to contravene. It's an offence to change or remove the date, and food is usually stored under refrigeration. A best before date is put on low risk food. It's no offence to sell after the date if fit. The manufacturer guarantees quality to this date. Foods are usually stored at ambient or in a cool, dry store. Date only valid if storage conditions are satisfactory. In other words, a use by date is a food safety date and a best before date is a food quality date. Food preparation. Under Regulation EC 852/2004, all food must be protected against contamination during handling, storage, packaging, display and distribution. And the hazards with food preparation include contamination and multiplication. Sources of hazards could include food handlers, structure, equipment, environment, pests and raw food. Good hygiene practices are prerequisites. Controls include effective separation of high risk from raw foods, colour coding, disposable cloths, good organisation and workflow, linear workflow. Minimise time high risk food is at ambient temperature. Minimise quantities prepared and avoid preparing too far in advance. Minimise handling. Separate sink for washing raw food. Follow food safety instructions on packaging. Monitoring for food preparation includes audits and inspections, which crops are quite often in monitoring. The time at ambient temperature, and the temperature of the food. The hazards with cooking and processing include contamination, especially flies and foreign bodies, multiplication, especially with slow cooking, and survival of pathogens, spores and toxins. Sources of hazards could include equipment, the environment, food handlers, pests and cleaning chemicals. Good hygiene practices are again a prerequisite. Controls include cooking to 75 degrees Celsius core temperature, heat source under whole of pan, stir liquids regularly, avoid slow cooking, especially with the centre of large bone joints at low temperatures, care with minced products and rolled joints. These should not be undercooked like with certain muscle joints which you can undercook. Ensure frozen poultry is completely thawed. Cook near to eating time. Protect from contamination. Care with copper and aluminium pans, especially for acid food. And follow any food safety instructions on packaging. Monitoring methods for cooking and processing include checking and recording times and core cooking temperatures, and always use a disinfected probe thermometer, and regular audits and inspections. And a quick note on microwave cooking: always follow the manufacturer's instructions, only use commercial microwave ovens, stir as instructed, allow standing time after cooking, and probe in several places to ensure thorough cooking. Cooling. Under Regulation EC 852/2004, where foodstuffs are to be held or served at chill temperatures, they are to be cooled as quickly as possible following the heat processing stage or final preparation stage if no heat process is applied, to a temperature that does not result in a risk to health. Hazards here include contamination, multiplication and spore germination, and possibly toxin production. Again, good hygiene practices is a prerequisite. And controls: it is a legal requirement to cool high-risk foods as quickly as possible. 90 to 120 minutes is the maximum recommended time. Reduce bulk prior to cooking. Recommended maximum joint size 2.25 kilograms or 5 pounds. Maximize the surface area and maximize temperature differential. Use blast chillers if available, as they preserve appearance, texture, flavour, nutritional value. If no blast chiller, use a cool, well ventilated store. Stand in a pan in a food sink in cold running water or use an ice bath. Use fan blowing over the surface of covered food. Food raised off surface, as most heat is lost from the base. And for large joints we can use the American standard, and this is done in two parts. The first part, to cool it to less than 21 degrees Celsius within 2 hours, then to less than 7 degrees Celsius within a further 4 hours. Another standard is the Camden standard, and this is in 3 stages. First of all, to less than 50 degrees Celsius within 1 hour, then to less than 12 degrees Celsius within a further 6 hours, and then finally to less than 5 degrees Celsius within 1 hour. Refrigerate when close to room temperature or immediately after cooling. Cover and protect food. Remember that not contaminating food after cooking is paramount. Keep separate from raw food. Liquids should be stirred and or decanted to maximum depths of 2.5 centimeters or about an inch. Monitoring for cooling includes check cooling times and temperatures, and regular audits and inspections. Reheating food. Hazards include contamination, multiplication and survival of spores and toxins. Again, good hygiene practices is a prerequisite. Controls for reheating are as follows. Only reheat just before eating. Food should be reheated rapidly to a recommended temperature of at least 75 degrees Celsius. In Scotland it's 82 degrees Celsius, and that's a legal requirement. Specialist regeneration ovens are recommended. Commercial grade microwaves and convector microwave ovens are also successful. Maintain liquid products boiling for several minutes. Minimize bulk and stir frequently. Never reheat food more than once. Protect from contamination. Then serve immediately or hot hold above 63 degrees Celsius. Follow manufacturer's instructions. Avoid long, slow cooking at low temperatures. Monitoring methods for reheating include checking the temperatures and times, and again audits and inspections. With hot holding, the hazards are contamination and multiplication. Controls include hold above 63 degrees Celsius until served, thoroughly cook food before hot holding, preheat hot holding equipment such as bain-marie, hot cupboards, etc. prior to putting in the food, use minimum quantities, protect the food from contamination, and stir liquids frequently. Monitoring really the same as reheating. Check temperatures and times, and regular audits and inspections. The hazards with serving food are contamination and multiplication. Sources of hazards include food handlers, equipment, pests, customers, structure, environment and raw food. Again, good hygiene practices is a prerequisite. Controls for serving food include serving food quickly, keeping below 5 degrees Celsius or above 63 degrees Celsius, in other words out the temperature danger zone. Minimize time high-risk food is at room temperature, and refrigerated buffets are preferred. Stock rotation, colour coding, small quantities, replenish regularly. Provide new containers of food, don't top up. Minimize handling. Separate staff for raw, high-risk and ready-to-eat foods. Protect from contamination, perhaps by the use of sneeze guards. Avoid customers handling food where they can pass on low-dose pathogens, and where serving equipment is too long to drop into food containers. Monitoring includes checking times and temperatures, regular audits and inspections, date codes and condition of food. Remove and destroy any product suspected of being contaminated or with damaged packaging. And a quick note on how customers can contaminate food or open food in retail premises: by sneezing, coughing, handling, spitting whilst talking, outdoor clothing, dogs if allowed in the shop, for example guide dogs, and smoking with mouth to hand contact, etc. Cook chill is a method of cookery, and it consists of 9 stages. The first of all, the hazards with cook chill are contamination, multiplication and survival. The 9 stages in cook chill are as follows. First of all, bulk storage, where you need to have temperature control and to avoid contamination. Preparation, including portioning if possible. The third stage, cook to a minimum of 75 degrees Celsius or possibly 70 degrees Celsius for 2 minutes. Portioning should be done in a maximum of 30 minutes, and it's better prior to do this before cooking. Blast chilling to less than 3 degrees Celsius within 2 hours of cooking, 2.5 hours for joints. Storage at or below 3 degrees Celsius and with good stock rotation. Distribution at or below 3 degrees Celsius in insulated containers used in refrigerated vehicles, which are not used for non-food or raw food. The 8th stage is regeneration, and this should be done at or above 75 degrees Celsius or 70 degrees Celsius for 2 minutes. and that's 82 degrees Celsius in Scotland. And start reheating within 15 minutes of removing from chill, and this can be done with infrared, microwave or forced air. And the last stage, stage 9, serving. This should start within 15 minutes of regeneration. The food must never go below 63 degrees Celsius, and all unused food must be destroyed. Safety rules are essential for cook chill, as the food is often produced for vulnerable groups, for example people in hospitals. So first of all, good quality raw materials from reputable and approved suppliers. A specification should be enforced. Raw products stored correctly at the right temperature and to prevent contamination, and the use or delivery in refrigerated transport. Take account of food not subject to cook chill, for example frozen peas, cooked gammon, chips, sandwiches, etc. Avoid cross-contamination. Ensure physical separation of non-compatible foods. Separate equipment, for example cutting boards for raw and high-risk foods, so the use of colour coding. Separate staff for raw preparation and high risk. The use of controlled thawing, perhaps in thawing cabinets operating between 10 and 50 degrees Celsius. High hygiene standards. Good hygiene practices, which are prerequisites to HACCP. Good personal hygiene. Suitably trained staff, especially in relation to control and monitoring of CCPs. Suitable temperature control throughout storage and cooking. A HACCP system. Date marking. Hygienic food containers. Life of 5 days only. That includes preparation and consumption. If over 5 degrees Celsius, consume within 12 hours. Over 10 degrees Celsius, destroy. Regenerate quickly after removal from storage. Cook chill is cost effective because there is less wastage, fewer staff turnover, fewer staff due to centralisation of cooking facilities. The energy consumption is reduced, there's less floor space, benefits of bulk purchase, better equipment utilisation, and 5-day week. Controls, HACCP is essential, and with microbiological guidelines, the total viable count, the TVC, should be less than 100,000 per gram. That's where some food has been kept at 2 days for 37 degrees Celsius under controlled conditions. Salmonella and Listeria monocytogenes should not be detected in 25 grams. Staphylococcus aureus and Clostridium perfringens should be less than 100 per gram. E. coli, and that's not E. coli 0157, should be less than 10 per gram. And 100 gram samples should be taken immediately prior to regeneration. Cook freeze, another type of cooking. Hazards here include contamination, multiplication and survival. Cook freezing has several stages. They include bulk storage, preparation and possibly portioning, cooking and possibly portioning, blast freezing to less than -5 degrees Celsius within 2 hours of cooking, and the temperature is then reduced to -18 degrees Celsius as quickly as possible. Temperature reduced to -20 degrees Celsius. The safeguards built into cook chill are not quite as stringent for cook freeze, but high standards of food hygiene are still essential. Next, packaging and labelling. The food normally has a shelf life of 12 months. Then regeneration, 75 degrees Celsius or 70 degrees Celsius for 2 minutes. And the last method of cookery we're going to look at is sous vide. Sometimes called sous vide cook chill or cuisine sous vide. Sous vide literally means under vacuum in French. So therefore it's a cook chill process in which food is sealed in a vacuum pack before cooking and chilling. It's what's known as an interrupted catering system. Hazards include contamination, multiplication and survival, possibly failure in vacuum, post-process contamination. Shelf life may be several weeks, therefore psychrophiles are a problem, such as Listeria, Clostridium botulinum type E. The process has several stages. First of all, there's storage and preparation, vacuum packing under anaerobic conditions. The product then is heat treated by controlled cooking using moist heat, and used in a low temperature over a long period of time. Then it's rapidly chilled, usually blast chilled, and stored at less than 3 degrees Celsius, and it's reheated for service. The food is not commercially sterile. Anaerobic conditions exist after cooking, so the safety relies on rapid cooling, maintaining the cold chain, and integrity of the pouch. Advantages include extended shelf life, less shrinkage, enhanced sensory quality, improved nutritional value. Disadvantages include significant capital and operating cost, limited number of suitable products, and there could be serious consequences if things go wrong. Controls include rapid cooling, storing at less than 3 degrees Celsius, maintaining the pouch integrity. Clostridium botulinum is controlled by preservatives, salt content, water content, shelf life, pH, and storage temperature of less than 3 degrees Celsius. And here are the key points for Lecture 8. Major hazards include contamination, multiplication, survival, toxins and spores. Good stock rotation is essential. First in, first out. It's illegal to sell or use food after it's used by date. We looked at canned defects. Chilled food storage at between 1 and 4 degrees Celsius. The legal requirement is at or less than 8 degrees Celsius. We looked at thawing raw meat and poultry. We looked at vacuum packs requiring refrigeration. Cook food and reheat to 75 degrees Celsius, that's 82 degrees Celsius in Scotland, and store at 63 degrees Celsius or above, that's the hot holding temperature. Cool hot food rapidly, then refrigerate. Temperature control after process is critical, and we looked at the following cooking processes: the cook, chill, cook, freeze and sous vide cook chill processes. In order to consolidate